Okay, here's a switching scheme I come up with. I'll try to explain here a little bit what I'm doing here with the switching scheme. In order to have the least amount of wiring coming in to the control box on my lathe, I'm going to use a multiple of switches here for speed control. If I were to use one switch, a ganged switch, there would be a lot more work involved. This is the least amount of wiring and least amount of work with the individual switches. Each one of these switches are a single pole double throw switch. Now the way this works is I have my two transformers right here at the supply here, and these transformers are connected to the bridge rectifier. Everything that's in this here is the supply box that's going to be on the wall. All this here that's hatched like this. This is the only part that's going to be on the lathe itself. Now, what I'm going to have here is, let's say that I have this switch in the up position right here, and this switch here being in the up position. Everything below this here is open on the switch here, so that means everything connected to it means this whole transformer is disconnected out of the circuit. Since this switch is on this up on top here, that means then that everything connected to it would be over here, so it would be this transformer. This would be the only thing connected in the circuit at the time. So let's look at it if the switch was on top here first and not in the bottom, like this. Everything connected to that would be the 1/2 of the transformer, which is around 20 volts AC, and that connects over to the bridge rectifier, goes down ground and comes back up through here and takes on 1/2 of the transformer. Now what this allows me to do is, this is my selector switch for low, high speed. This selector switch here is for low, medium, low. This selector switch here would be medium, high, and high. The reason is because when this is in the up position, only 1/2 of the first transformer comes on. If I switch this now to the medium low position, which would be down here now, that brings the whole transformer, which is 40 volts AC voltage coming in, into the circuit now to drive the rest of the circuitry. Now, if I switch this here selector switch down to high down here, that means everything above here now is out of the circuit as far as the switch is concerned. But because this transformer is connected directly to the rest of the supply, this transformer will always be in here. What happens is, when this is switched down this direction here to the high position, that brings this transformer in with this transformer here now. So now this switch here has no bearings on it whatsoever because it's disconnected here. But what happens is now, depending on where this switch is located at, if this switch is on the top position here on medium high, current will flow from the top of this transformer all the way down to this transformer here, out the center tap, through the switch contact, and then through this switch contact, through the circuitry, and back around. That takes 1/2, so it takes one full transformer plus 1/2 of the next one. If this switch is down in the high position now, as it is now, that means then that this transformer plus this transformer, which are getting close to 80 volts, 40 volts here and 40 volts here, will give me both transformers will both be in the circuit now to give me the full power and the full speed output. So what this here first switch does is this gives me the option of having low and medium low, 1/2 a transformer or one full transformer, which is 20 volts, 40 volts. When I switch this to high, it then gives me the option of having 40 volts, 60 volts, or 80 volts. It takes the full transformer here, which is 40 volts, and adds on 20 volts here, center tap, or the full transformer, which is 40 volts, gives you full 80 volts. That's the switching scheme that I've come up with for this. Okay, I do need to make one correction on the voltages that I was giving here. These are 24 volt center taps, which means is that 28 volt center taps is called, which is 14 volts on each half. All right. what I was given the DC voltage after it's been filtered and rectified, and that takes about 40 volts. On AC, it's around 28 volts full transformer, 14 volts half center tap. But by the time I get to the filtering and the rectifying, it comes out at DC of 40 volts, and that's what I was given. That's where I was given the number 40 volts. But anyway, that's what it is. It's 18 volts. it's 14 volts, 28, and then 28 plus 28 here gives you 56 volts altogether. And of course, you take that times 1.414, and then you go through all this here stuff and everything. It gives you a DC voltage, the peak AC voltage, and blah blah blah, and it gives you a high voltage on the DC, which I was getting mixed up there when I was telling you that there. But that's how this here scheme works now. All right, here we go. Okay, gathering my components here a little at a time. I have a bridge rectifier here that goes right here, and that's going to have 3 terminals. For that, I'm going to need a 4 terminal for this to sit on. So I'll go over here. I got 4 terminals here on that could be for the bridge rectifier, and that can take care of these inputs here, plus this output here coming here that goes into there. So that could take care of 1, 2, 3, and 4. That would take care of those. I have a 2 socket here, so I can get a 2 terminal for 2 here, 2 socket for that. And now that would leave me with 3 right here, and I have that right here, 3s, and that would take care of that. So 3, 7, 12. Let me see here. I'm gonna need 9. So let's see here. Yeah, that takes care of all 9 right there. So these are the terminal blocks that I'll use for this, and I'll get that established now onto the platform. Still going to need to put one of the AC wires here in the same side as this here, so I have room on the other side to go to the circuit. That'll be at this one right here. I'll have to figure out which one I'm going to use, which transformer I'm going to use for this, and then I'll put that wire in with this on the AC side here. Okay, if I use this wire down here on the secondary, that's the bottom wire here for the AC input, that would be here. That means the other wire, which is on this side here, would be right here. This would have to connect to the top of the next one, which is actually the bottom of this one here. So to keep this in series, this would be the input here, this would come out of here, this would tie into the bottom one. Top one here would tie into the bottom one here, so that the top one here becomes the bottom in the series together. Would be this bottom one down here, would be this top wire here on this one, to keep it all in the same phase in series. So this one can go into the AC input here on this side here. Like that. Because I need this side of the terminal block here to go to the to wire out to the circuit. That's why I want to put all this on the same side here. I got plenty of room here with the screw. Okay. That would be the top of the transformer there. This would be the bottom. This now will tie in to this one here, which I can use a wire nut for that. That would be a wire nut here. Tie the two together. And then later on I'll tape that up once I'm satisfied with the performance of this. Alright, and then this here bottom here now, or should I say the top wire here now, is actually the bottom of the series. Starting here, going through here, up through here, and out through here. That's the way that would have to be in series with each other, just like that. Alright. Okay, now I'm going to work on the AC power coming in to the transformers. That would be numbers 9 and 8 here. That'd be a 2-terminal block. I'll put that right here. In that area there. I'll go in there. Okay, with this wire in here now, make sure everything's in phase. I'll take the top 2 wires. That is the top 2 primary wires. And I'll put them in the first terminal here. Make sure those are the top ones. And they'll go in the front. I'm probably going to have to strip more wire the way it looks. We'll try it this way first. Okay, that's the top ones. So make sure everything's in phase. Oh, I have to strip more wire. I don't have this thing set on my wire clippers here. Right size here. Here we go. Some solid insulation each for that. Of course, I don't have these here wire cutters set right here. Okay. Now we'll go with the top wires. Got more lead here now. Am I even recording? Yeah. They're ready. Go in there like that. And the two bottom wires now. Make sure the bottom, put them together. And that makes sure that they're in phase that way, as they need to be. I want power to come to both both transformers at the same time. The transformers are only in series on the secondary windings, but they have to be in parallel on the primary windings in order to be work properly. Now what I'll do is I'll give a continuity check. I'll give a continuity check to make sure that everything is, I should be getting some sort of resistance reading across here now. Good, it's continuity, which means that it is getting through. It means that the bare wires are connected in here properly. Alright. Okay, and the one last terminal block now. Whoops, I made a miscalculation. I have 10 terminal blocks, 10 terminals here, not 9. I have this 3 terminal comes off and that becomes a 4 terminal, and then now I have everything I need. Now it's a 4 terminal block. Now I got it. Alright, now, following my wiring diagram here, this wire right here, okay, everything that comes off of the bridge rectifier, that would be number 1, 4 is the output, 2 is this wire right here, and 3 will be the one that goes back into the switch. The center taps and the other parts of the transformer here will be 5, 6, 7, and 8, and I'll put those terminals in next now, those wires. Okay, so number 5 here is the center tap of the first transformer, which is this one here is the first one. Here's the center tap, and that will go to number 5, and then we got 6, 7, 8. So number 5 goes here. That's number 5. Okay, that's number 5. Number 6. Number 6 will be the one that's tied together, which is right here. So that's going to have a wire going into here then. And let's go to number 7. 7 is the center tap of the second one. 7 is the center tap of the second transformer. So the center tap right here is number 7. So 5, 6, number 7 is this one here. Okay, that's number 7. And then number 8, of course, would be the last one right here. And number 6 here has to have a wire put in that combines the first 2 wires with the wire nut. There's number 8, so now this one here has to go number 6. Alright, this will be number 6 here, this wire here. number 6 right here. Okay. We'll plug her in and we'll check voltages. I have to get the capacitors now in here as well. Alrighty, this one here is wire number 4, the output. I'll put that on this side here. Okay, and that can be wire nutted on to the positive, which is right here. Use a wire nut for that. And I'll tape this up later on. That's the positive for the capacitive filter. And then this one will go to the ground, which is over here now. So that requires a bit more wire here. About like that. That goes to ground. Okay. And then that gets wire nutted on over here. Power comes in over here, output comes over here, and we have, what we can do now is actually check voltages here now and see what we have on voltages, make sure that we're getting our DC voltage out. Okay, what I'm doing now is I'm connecting temporary number 8 output of the transformer to number 3. And that takes the place of the switch right now. I don't have any of the switching arrangement right now, but I just want to test to make sure both transformers are in the circuit properly. So I take number 8 here and I connect it back to 3, and that will bypass the switches and go right directly back into the bridge rectifier, and then that will let me know if the transformers are hooked up. So I'll check a voltage reading across here, negative to positive, when I plug this in. One last wire to hook up here, that'll be the supply wire coming in, and eventually this will get fused, an inline fuse, when I get this thing set up permanently. Right now I want to check the voltage. When I plug it in, I want to check the voltage across here, across the bridge rectifier from negative to positive, to make sure I get close to anywhere between 70 and 80 volts DC. Okay, here we go. Here's negative, here's positive. Okay, 85.9 volts DC. So I'm getting my voltage to between two transformers, the full 2 transformers. 85.9 volts DC. It's working properly. Now I unplug it and make sure the capacitive filters are working properly. It should still stay at 85.9 volts in that range, and it's staying there. So we're still at 85 volts. So the capacitive filter is holding a charge. So everything is connected properly, is what this means. Everything's connected properly. Now I need to discharge the capacitors. Okay, so that makes everything working pretty good now. All I have to do now is do the switching arrangement and then start building the circuit boards for the voltage regulators and the torque control circuitry. But this part's pretty well accomplished now for the unregulated power supply. That part's done, and it's ready to be added onto now to make it into a regulated power supply with torque control for my mini lathe. Okay, that's all for this evening. Thank you for watching. Bye.